In this lesson, we will solve rational inequalities. Starting with the rational inequality, x minus 3 over x squared plus x minus 2 is less than or equal to 0. Let's call this function to the left of our inequality sign f of x. So we have a rational function f of x, and I'll start by factoring f of x. F of x factors into x minus 3 over x plus 2 times x minus 1. And I'm going to look for the values of x that would give me zeros at each of these factors. If x minus 3 is equal to 0, that will give me x equals 3. These are the numbers I will put on a number line that we will use for a sign chart. If x plus 2 equals 0, then that will give me x equals negative 2. If x minus 1 equals 0, that will give me 1. Okay, so let's see what's going on at each of these values of x. At x equals negative 2, I would have a 0 in my denominator. We can't have that, so I'll put a little frowny face here on the graph. If x equals 1, same thing. We would have a problem. We would have a 0 in the denominator. At x equals 3, we would have a 0. And so we'll put a 0 above the x equals 3. And then let's find a test value in each of these regions and determine if we have positive or negative values for f of x. If x is less than negative 2, I will choose negative 3. So I'll have negative 3 minus 3 over negative 3 plus 2, negative 3 minus 1. A negative divided by a negative times a negative is a negative value. And same thing in the next interval, I'll choose x equals 0. We'll have a negative over a positive times a negative, which will give me a positive. The next interval from x equals 1 to x equals 3, let's choose 2. We'd have negative over a positive times a positive. So f of x will be negative here. And the interval to the right of x equals 3, let's choose 4. We'd have a positive over a positive times a positive. So the signs are positive there. So we have a sign chart here telling us what's going on with f of x, and what we want to happen is we want f of x to be less than or equal to 0. That's when we'll have a solution to this inequality. So when does that happen? That happens to the left of negative 2, but not at negative 2. So our solution would be negative infinity to negative 2, not including negative 2, and then again starting at 1 to 3, and here less than or equal to 0 includes the 3 here. So from 1 to 3 including 3. So our solution here will be the open interval from negative infinity to negative 2 union the interval from 1 to 3 that does not include 1 but does include 3. Let's solve the rational inequality. X minus 1 over x plus 3 is greater than 2. Here we have another problem. We don't have a 0 to the right of the inequality sign, and that's a requirement. So let's see if we can work with this to get a 0 on the right hand side. I'll subtract 2 from each side. And then I also want one fraction on the left side. And so let's see if we can do that. I want to put 2 over my x plus 3. So I have minus 2 times x plus 3. And then I'll simplify a bit. I have x minus 2x, so I'd have negative x. I have negative 1 minus 6, so negative x minus 7 over x plus 3 is greater than 0. So we'll proceed as we did with the last one now. We'll call this f of x to the left of the inequality sign, and it's already factored. What we want to do is we want to create a sign chart using the values of x that would give me zeros in these factors. So if I put negative 7 in for this x in the numerator, I would have a 0 there. And if I put negative 3 in the denominator for x, I would have a 0. So let's see what's going on at each of those. Negative 7 would give us a 0 for f of x. Negative 3 would be a problem for f of x. It would give us an undefined fraction, and so we'll put a frowny face at -3. Okay, and let's test each interval for f of x. Let's look at a number less than -7, maybe -8. If I plug in -8 into f of x, I'll have the negative of -8. So 8 minus 7 would be positive over -8 plus 3 would be negative. So we'll have negative values to the left of -7. Between -7 and -3, I could pick a test value of, say, -4. I'd have the negative of -4 and minus 7, which would be negative over -4 plus 3. So my f of x will be positive between -7 and -3. To the right of -3, we might pick 0, which would give me a negative over a positive, resulting in a negative. And so f of x is negative to the left of -7, positive between -7 and -3, negative to the right of -3, and 0 at -7. We're looking for f of x being greater than 0 here, and that only happens between -7 and -3. So we have the open interval from -7 to -3 that would be our solution here. Try on your own. Solve the rational inequality x minus 1 over x squared minus 2x minus 8 is greater than or equal to 0.